The intermediate value theorem is one of only a handful of named theorems that we're going to be discussing in Calculus 1. This intermediate value theorem is a consequence of the concept of continuity, and so we're going to discuss it at this point. That theorem states that if a function f is continuous on a closed interval, so you see that continuous there as being an assumption for this theorem. So we have the function continuous on a closed interval, then for any k strictly between f of a and f of b, so these would be y values since we're talking about function output values, there would be at least one c in the interval ab, the open interval ab, so that c would be an input value, so an x value, such that f of c is equal to k. So just to kind of get a visual of what this could look like, let's say we have an interval, a closed interval AB. So I'm going to go ahead and put the endpoints there as closed so that you see when we were to plug in A to the function, perhaps we have a function value f of A up here. And perhaps we have a function value f of b lower. It doesn't really matter whether it's lower or higher, but we've just got two function values there. So what the intermediate value theorem is saying is that every value, every y value in between is achieved because we have continuity. So because of continuity, every y value that we pick in between here, so we see here k, is just some arbitrary value in between f of a and f of b, we would be able to find a place on the function that reaches that value k, and we could trace back to our interval and find at least one value c strictly in between a and b, so in the open interval ab, such that when we input c, we get the output of k there. And the thing that I really think about here for the intermediate value theorem is because of continuity, every value in between, that's the intermediate value, every value in between f of a and f of b is achieved somewhere coming from an x value in your original interval, strictly inside the open part of your original interval for x's. So in talking about this theorem, we really want to understand why continuous is important. So let's think about what we might get if we didn't have continuous. So we'll start here at on the x-axis with our interval AB there, a closed interval. Again, we could have this function value up here of f of a, and a function value lower here, again, lower isn't important, I'm just doing this as a demonstration, of f of b. So now the fact that the intermediate value theorem required continuity meant I could not pick up my pencil and going between those dots. And the intermediate value theorem said because of that, every y value is achieved. But see, if we did not have continuity, then we could just go ahead and do this switchover place. We could use a discontinuity that would then mean that some value here in between, and really a lot of values here in between, we never can find a place for the function to where it hits. And so we would never have that value of k as an output value because we just jumped right down from f of a level down to f of b level using a discontinuity. And so never did that function have as an output value k. And so we would be utilizing that jump discontinuity in this example to miss a value in between, an intermediate value in between. And so the continuity of a function is really key to making this conclusion work.